For those of you that missed the thermal expansion lab, I'm going to model it for you, or if you need to go back and rewatch it, this is here for your reference. This is on the back of worksheet 2, which says phases of matter and thermal expansion. The lab procedures and everything you need is right here on the back. What we're going to do is go through and make some predictions, and then I'll complete the lab, and you should be going along and filling this in as you go, and then you'll answer these questions at the end. Okay, our first step is to predict what's going to happen to the ball or sphere and the ring when they're hot and they're cold. So here they are at room temperature, and the first prediction you need to make is what's going to happen when I try to put the sphere through the ring. Will they fit? Yes or no? You're going to fill out your first prediction right on your worksheet under the part that says prediction and before heating. So this first spot right here, and then I'll go through and read off, and you're going to fill in the rest till you get to the last one. Okay. First one says to predict, will they fit before heating? So right now at room temperature without any heat, will they fit? Take a minute and write a Y or an N. Y for yes, N for no. All right, now watch. Okay, they do fit. So that's our observation. So down below your prediction, in that first column, under observation before heating, you're going to write down that yes, they do fit. Now, we learned that molecules expand when they get hot, so what I'd like for you to do is to predict when we heat up the sphere and it gets hotter and those molecules expand, then we're going to test, will it fit through, yes or no. Then we're going to put the hot sphere in this water right here. It's going to fizzle and pop, and once it's done, it'll be cold. We'll pull it out, and then we'll test again. You're going to write down your prediction. At this point, will they fit through, yes or no? Now that we've heated and cooled the sphere to test, our next step is to test the ring. So we're going to heat the ring over the burner. Once the ring is good and hot, we'll test again to see if the sphere fits through. What I'd like for you to do right now is to write down your prediction for the ring. When the ring is hot, will the sphere fit through, yes or no? Okay. After that, I'll then heat both the sphere and the ring together. We'll hold them both over the burner like this, and then we will test them together. Will they fit through when both are hot? Okay, I'm going to go through and now show you each of these steps, and as you're watching, you're going to record your observations, either a yes or a no. For yes, it fits, no, it will not fit, in each of the columns on your worksheet. So what I'm doing right now is lighting the butane burner. I don't know, it's hard to see the flame here. It's a hot blue flame, and I have a timer down here that I'll be using. And the first thing we're going to do is heat the sphere. I'm going to put it directly in the flame the whole time. And your directions say to heat it a minute, but I'm actually going to heat it about a minute and a half, maybe even a little longer than that, to make sure it's good and hot before we test. There's a little bit of a fizzing noise happening right now, and there was some water on the sphere that has fully evaporated off. I'm rotating the sphere to make sure I'm heating it evenly. It's kind of like roasting a marshmallow. It's been 40 seconds so far, so we're about halfway there. I'm going to turn the flame up just a little bit. Alright, we're at 1 minute and 6 seconds. Like I said, I wanted to give it a good minute and a half. I found that while our directions say 1 minute, a little bit longer produces better results. I want to make sure the molecules inside of the metal sphere are good and hot. So we are giving them more heat energy. As they are heated, they are gaining heat energy, or it's increasing. And we know that when molecules have more heat energy, it allows them to move faster and to spread apart. So with that knowledge, we're going to see if we can prove that they've actually spread apart. All right, it's been just about 2 minutes. I'm going to take this out. I'm going to put it through. And what you're going to notice is that I no longer can get the sphere through the ring. The molecules inside of the sphere have expanded enough that they cannot pass through the ring because the ring's molecules haven't expanded because we didn't heat them up, only the sphere. This is going to fizz, but I'm going to put it right in the water and cool it off. Okay, now that it is cool enough, we're going to take it out and test it. And we can see that once it's cool, it fits through easily. Okay, our next step is to heat only the ring. We're going to heat this for a minute. I'm going to rotate it periodically to make sure all sides of the ring are good and hot. So at this point, we're going to see how the molecules expand inside only the ring, and we're going to leave the sphere cool. Another 30 seconds or so to go. Okay. Now I'm going to test. And the sphere fits through very nicely when just the ring is heated. So as the molecules in the ring expand, what is happening is that the ring is becoming larger, and it allows for the sphere to pass through even more easily than when the ring is cool. All right. We'll cool that off and test. And once again, at a cooler temperature, the sphere can still pass through the ring. And our final step is to heat both together and see if we can not only have the molecules expand in the sphere but also the ring, and we'll see if when they both have expanded, if the sphere can pass through the ring. So I'll hold them both in the flame and I'll periodically rotate them. Once again, you can see that the water that was on both the sphere and the ring is slowly evaporating off into the air. Now I'm going to take them off the flame and we're going to test. And when they are both heated, the sphere can still easily pass through because the molecules in the sphere have expanded, but the molecules in the ring have also expanded. So that's everything you need to complete your thermal expansion lab. I'm going to turn off the burner. I'm going to cool both the sphere and the ring. Your last step is to go through and answer question number 3, which is right here at the bottom. And it asks you, it says, describe why the blank sphere would not pass through the ring. The word you're going to want to fill in is heated because it was the sphere that was hot that would not allow the, that could not pass through the ring. You're going to need to talk about the motion of the molecules, the heat, energy, and the volume of the sphere in your answer. Just to kind of go back over that one more time, when the sphere was heated or put over the flame, it was able to gain more heat energy, and as the molecules inside had more energy, they were able to move more, so their motion increased, and that allowed them to spread apart just a little bit. Because the molecules were moving more and spread apart further, the volume of the sphere increased, and we observe that this is the case because the sphere would not pass through the ring. If the volume had not changed, it still would have been able to pass through. So that's everything you need. Make sure you complete all of this in whole sentences. And the front part of this paper you can complete by opening up the Phases of Matter Stations questions, which are also posted on my website, and you can just go through and answer all of them in order by pulling up the questions. So this should be everything you need to complete today's classwork, even though you were absent.